Hi there, welcome to this SUVAT exam style question video. We're going to learn how we can solve SUVAT exam style questions in this video. So just to remind ourselves of SUVAT equations, there are five SUVAT equations you are required to remember. And I always suggest to students to remember these off by heart, even if they are given to you in your exam, because it can be quite difficult in sort of an exam condition to have to look back at the equation and try and remember what each equation is, how to use it. So just for practice, try and memorize these equations off by heart and in which scenarios do we use them. So not focusing too much on theory, let's go straight to exam questions. So this is an exam question from the OCR 2018 June mechanical paper for OCR. And here, if we just read the question out loud, a toy boat of mass 1.5 kilograms is pushed across a pond, starting from rest for 2.5 seconds. During this time, the boat has an acceleration of 2 meters per second squared. Subsequently, when the only horizontal force acting on the boat is a constant resistance to motion, the boat travels 10 meters before coming to rest. Calculate the magnitude of the resistance to motion. So it's really important with these types of questions to visualize them, because there's a lot of different parts of the journey and we're not quite sure what's happening when. And by visualize, I mean draw a diagram. So that's one of my first key tips for you when you're doing these SUVAT exam style questions. Draw diagrams. It's really important, and label those diagrams. So let me show you an example here. So you've got this boat. It's got 1,500 newtons of mass, and it starts from rest. So U is equal to 0. Starts at rest 0. It's being pushed across the pond with acceleration 2 meters per second, and it's got a so its acceleration is 2. Its final velocity we don't really know, so the final velocity v we don't quite know. And is there any other variables? Yes, time. So time is 2.5. So here I'm trying to find what v is, because for the next part of the question there is only a horizontal force acting, so there's no more acceleration, there's only deceleration, and we want to know the magnitude of the force that causes that deceleration. So for us to know that, we need to know what the final velocity after this initial acceleration is. So if we go back to our equations, we've got u, we've got a, we've got v, and we've got t. So from our equations, we can say that v is equal to u plus at. That's the equation we're probably going to be using. So v is equal to u plus at. So v is our unknown, u is 0, plus 2 times 2.5. So the final velocity after this first part of the journey is 5 meters per second. So that's the first part of the question done. Now let's look at the second part. So subsequently, this is our first part. Now let's try figure out the second part. So the second part is subsequently, when the only horizontal force acting on is resistant motion, boat travels 10 meters before coming to rest. So again, we can find out our variables. Well, we know that the initial velocity at the start of this journey is 5 meters. We know that the final velocity is 0 meters. We know, so we've got v, we've got u, we've got s is equal to 10. Now, what variable should I try and find? Well, if I want to know force, I've got mass, I need acceleration, right? So if I want to know force, so I need to find acceleration. To find this, because remember the question is asking to calculate the magnitude of the resistance to the motion, so that means the force that's resisting the motion. So right now the object is going this way, and we want to find out what force is pushing it back. So this is the next part of the question. And so for this one we can use v squared.